So odd, highest power on x, ends go in opposite directions. Even, highest power on x, the ends are going to go in the same direction out of that. So C part says write two equations of that same form with graphs that you predict the quadrants in quadrants 1 and 2. Write the equations, the graphs that you predict are in quadrants 1 and 3 out of that. So if it's going to be in quadrants 1 and 2, what kind of exponent has to be there if the ends are going to be going in quadrant 1 and quadrant 2? Which ones both went this way? Odd or even? Even. Okay. 1 and 3, here's 1, here's 3. So we would need an exponent that's what? Opposite of even is odd. The ideas that I'm throwing at you here are what I'm trying to get you to hang on to. I know you've been out for a week. Re-engage. We gotta work our way through it. All right. Now, essential question: how do the key features of polynomial function help you sketch the graph? So, the idea here on the first example is how can you write the polynomial in standard form and use it to identify the leading coefficient, the degree, and the number of terms. Okay, so standard form. That's standard form is descending order. By powers of x. Okay? So what is the highest power of x in example 1 there? 2x to the third. So we're going to write 2x to the third first. Then the next highest power of x would be negative 4x, right? So we're going to write minus 4x. And then plus 9 is the last piece. So that is standard form. So this is standard form. Because it's in the right order. Now, the next thing it said was identify the leading coefficient and the degree. The degree is the highest power of x. For a polynomial, it's going to be the highest exponent. So our degree is 3. Our leading coefficient, what's a coefficient? Yeah, 2 and negative 4 are coefficients. 9 is technically a coefficient. It's a constant, but it could be the coefficient of x to the 0 power if you wanted to think about it that way. But the leading coefficient is the one that's in front, 2. So the leading coefficient is positive 2. Now the number of terms, how many pieces are there? There are 3 terms. 2x to the third is a term, minus 4x is a term, plus 9 is a term. So 3 terms out of that. It has a degree of 3 and a leading coefficient of 2. Because it has a degree of 3, what do we know about the ends? Are they going the same direction or opposite directions? Opposite directions. Okay? The leading coefficient of a positive 2 makes it act like a positive slope. So the right side would be going up, the left side would be going down. That's the things we got to start picking up on and learning in this lesson. Is based on the degree and the leading coefficient, we should be able to tell what the ends are doing. The rest of the stuff, that's the details. That's the ups and downs, the peaks and valleys inside of the graph. But the degree and the leading coefficient are what's going to tell us the end behavior of the polynomial. All right, so let's try to put a couple of them in standard form here. and get the leading coefficient, degree, number of terms of each polynomial. So let's try to put A in standard form. What should go first? Yeah, make sure you take that sign with you, negative 3x to the fourth. What's next? Yeah, minus 5x cubed plus 2x plus 6. Yeah, so there's standard form. It has a degree of 4 and a leading coefficient. I'm just going to abbreviate leading coefficient LC, negative 3. And it has 4 terms. All right, so degree of 4. So we know both ends are doing what? Going the same direction or opposite? Same direction. Because the leading coefficient is negative 3, they will point down. Remember on a quadratic, if A was negative, it opened down. Same rule applies to polynomials. If it's even degree and a negative leading coefficient, it's going to open down. So we know the ends will both go toward negative infinity. That's what we're going to pick up from that. Okay. See if you can do B part. Get it in standard form. Get the degree and the leading coefficient and the number of terms. Oops. I didn't have my hand over the top of that person. So check your standard form. 2x to the 6th plus x to the 5th minus 3x to the 4th plus 4x cubed minus 8x. The degree is 6. The leading coefficient is, how many terms do we have? 5. All right. Not hard. That's the easiest thing we'll do all day. I mean, honestly, that's an easy thing. Okay. All right, so here is kind of taking what I've been talking about with end behavior and putting a picture to it and what's going on there. So a polynomial function whose the end behavior of the graph describes what happens to the function values as x approaches positive and negative infinity. So we're talking about as we get out to the left extreme values and to the right extreme values. So as x is really, really big to the right or really, really small, really negative to the left. That's what end behavior describes. It's describing what's happening with that. So the picture here, the first one says an odd degree polynomial. So the highest exponent on x would be a 1, 3, 5, 7, 9, so on, that sort of thing, with a positive leading coefficient. So the leading coefficient is a positive number. If that's the case, it's going to act like a line with a positive slope. So the left side's going to go down, right side's going to go up. That occurs for x to the 3rd power, x to the 5th power, x to the 23rd power. Anything that's an odd degree with a positive leading coefficient acts like y equals x on the ends. Okay? If it's, go right below that, odd degree with a negative leading coefficient, it acts like y equals negative x. Left side's going up, right side's going down. So as x goes to negative infinity, f of x goes to positive infinity. As x goes to positive infinity, f of x goes to negative infinity, or the y values go to negative infinity. That's what we're dealing with there, okay? So odd degree, think about a line. That's the most basic polynomial with an odd degree is y equals x. The end behavior is the same for any odd degree polynomial as if it was a line. So no positive slope, negative slope. If you know that, you can know end behavior. And here's the kind of the catch on this. What they're going to do is give you a polynomial that you just can't type into your calculator and see the whole graph. They're going to give you coefficients that are so large that it won't show you the whole graph. So you won't be able to just type it in and look. You'll need to know these rules out of that. That's kind of what they're wanting you to learn these rules out of that. So odd degree polynomial, positive leading coefficient, left side down, right side up. Negative leading coefficient, left side up, right side down. Even degree polynomial acts like a parabola. So even degree with a positive leading coefficient is a parabola that opens up. Both ends are going to positive infinity. If it's got a negative leading coefficient, it's like a parabola with a negative leading coefficient. Both ends are going to negative infinity. That's the rule. Always. For any polynomial. No matter how big the degree is, if it's odd, positive leading coefficient acts like a positive slope line. Odd negative leading coefficient acts like a negative slope line. If it's even with a positive leading coefficient, it acts like y equals x squared. If it's even with a negative leading coefficient, y equals negative x squared. That's what it always acts like. So let's try to pull that off on these two. Okay? So use the leading coefficient and degree of the polynomial to determine the end behavior of each graph. Okay? So the nice thing is on A part that they've already got it in standard form for us. So all I need to know is what's the degree and the leading coefficient. So that's a even degree with a positive leading coefficient. So as x approaches negative infinity, that means as we go left, f of x goes where? Positive infinity. As x approaches positive infinity, in other words, the right side, f of x also goes to positive infinity, so up. Okay. The x approaching negative infinity, f of x approaches positive. That's a more formal way of writing it. Left side up, right side down, or right side up. That's the informal way of reporting that. They ask for it in both ways in Algebra 2. And in college algebra, we do this same thing in there, and they do it both ways in there too. So just knowing this formal definition here, and then just easy words type thing. Okay. What about example B there? What's the degree? 3. The leading coefficient? -5. So as x goes to the left toward negative infinity, f of x goes which way? So we got a negative leading coefficient with an odd degree. No. Because it's a negative leading coefficient and an odd degree, it's going to act like a line with a negative slope. That's how it's going to, and it's just learning that rule. Once we figure that out, we're good. So left side's going to go up, so that's going to go toward positive infinity. As x approaches positive infinity, f of x will go to negative infinity. So as we go to the right, it's going down. And it's just learning the degree, even degree, you're always going to have the same thing on your y's. They should always go the same direction. On the odd degree, they should always go opposite directions. The key is the slope. If it's positive, it's going to be left side down, right side up. If it's negative, it's going to be left side up, right side down. Out of that. Learn that rule. That's going to be key to being able to do that. I didn't do a good job on making your copy there. I didn't get this example in the right spot. But find that. Consider the polynomial. Can you use a table of values to identify key features and sketch the graph of that function? So we're going to talk about what key features we're even talking about, and then go from there. So good thing for us is that if we're making a table of values, we've got a calculator that'll help us. If we're looking for a graph, we've got a calculator that'll help us graph it, right? I mean, that we've got that tool out of that. But the key features that we want to focus on are some important places. So we could talk about the intercepts. Anytime you're talking about a graph of any kind of equation, intercepts are always going to be important key features of that. So that's an important thing that we'll look at. And then we'll talk about end behavior, what we just used. Talk about turning points. And turning points are maxes and mins. Okay? Turning points, end behavior, x-intercepts, y-intercepts. Those are key features that we're going to look at for this graph. So we're going to graph this with the calculator and see what's happening with it. So I'm going to type in, I'm going to go clear out all this other junk that I had going on. And I'm going to type in negative 0.5 x raised to the fourth. Dang it. Plus 3x squared plus 2. Before I even hit graph, what do I know about the ends of this graph? Both going to be down because it's an even degree. 4 is the highest power, right? And it's got a negative leading coefficient. So we know it's going to open down. We know that before we even look at the graph. The graph. All right. So this one, because of the other pieces, it has some peaks and valleys. Okay. So we've got some intercepts here. So we know that on this graph, so on your paper there, what I would do is I would kind of draw myself a coordinate plane. Doesn't have to be real big. But then I'm gonna put some of those points there. So I see it crossing the x-axis between -2 and -3. So I would go over there and I'd put between -2 and -3. I'd just make me a little point right there. And then between 2 and 3, +2, +3. It's got an x-intercept right there. So that's a key feature. And then what else do we see there with this? The y-intercept is 2. That's important. There's me a point right there. What else do we see on that graph that would be in that list that we had? So we did intercepts, x and y intercepts. Next thing was end behavior. We talked about that in even degree. They both went down. We know that we typed it in correctly because we know that rule. Now, what else? The last thing in there that listed 3 things was turning points. So what are the turning points on this graph? We got a point right here. It goes from increasing to decreasing. So that's a turning point. So that would be a relative what? Maximum or minimum? Maximum, because it's a top of a peak. Here, this would be a relative minimum. It's also a turning point, and that's another relative max. So good news is we have a tool on our calculator to actually find those points for us, and I want to show you how to use that. So the calculator, you can hit second trace, and it'll pull up this calculate menu, and it can find a given value. Like if you put in an x, it'll find the y value. We already know how to do that. It can find a zero. What's another name for a zero? What intercept? An x-intercept. So we could get it to tell us those x-intercepts. Let's do that. So I chose option 2, and it asks for a left bound, and it's going to ask for a right bound. So if I want to find this one, the left bound needs to be to the left of that point. So I'm going to move my arrow over here to the left, and that is definitely to the left of that x-intercept. So I'm going to hit enter. Then I'm going to move to the right, and that's definitely to the right of that x-intercept. And I'm going to hit enter again, and then it asks me to guess. I'm just going to move back a little closer to it and hit enter. And there it found negative 2.57 and some change. And then over here it has negative 1 e to the negative 12. What is that? That is scientific notation. What is that as a number? So it said negative 1 e negative 12. That's the same thing as this. What is this as a number? Like a standard form number. Negative exponent means we move the decimal place to the left 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is that close to? 0. So it's a rounding, and what it is the algorithm that the calculator uses to find that 0. There's a little bit of a rounding error there. This right here is essentially 0. Sometimes you'll put it in there and it'll actually give you 0 right there, which is no brainer. But sometimes it gives you a weird looking thing like that. Just understand that's 0. That's all that. Because we were finding a 0, right? And that's what the calculator is using the algorithm to run that and find that 0. So this is really just 0. So the negative 1 e to the negative 12 is really just 0. So we have an x-intercept, and we're going to go and we're just going to write, hey, that x-intercept is there at negative 2.570. And then I'm going to go and I'm going to find the other x-intercept. Second trace, go to 0, and my left bound, I'm going to move over here to the left of my other 0, hit enter, move to the right, hit enter, move back a little closer to it, hit enter. There's positive 2.57, and then there's that negative 1 e to the negative 12 again. Again, it's a rounding error in the algorithm that it's not really an error. It's your calculator just doesn't have enough memory to handle that. If we're running this on a PC or something, with a much bigger memory capacity than the graphic calculator, it's probably going to be able to handle that to a 0 out of that. But using the calculator's given parameters. So 2.57 there. So 2 point, and they won't always be the same number with every problem, but that's what this one ends up being. So we got the x-intercepts. Those are important. The y-intercept there, let's check that value at 0. So I'm going to hit trace 0. And as Jacob told us that 0, 2 was the y-intercept, that's exactly what that is. So that y-intercept is at 0, 2. So there's your key features. Now we also want those maxes and mins. that we found out of that. So I'm going to use the calculator to help me find those. If I hit second trace, it has a tool for finding a minimum. It has a tool for finding a maximum. And it works the same way as the zero tool. So let's go to the maximum. So go down to option 4. And I'm going to find this maximum over here on the left. So the left bound, I just need to be to the left side of the peak. So hit enter. The right bound, I just need to be to the right side of the peak. Hit enter. On the guess, I just move back a little closer to it and hit enter. This ordered pair is my maximum. Negative 1.73. We're rounding it to 2 decimal places. That's pretty common for a textbook here. So negative 1.73 and then 6.5. That's that maximum. So I'm going to estimate where that's at. Negative 1.73, 6.5. 1, 2, 3, 4, 5. 6.5 is about right there. So negative 1.73, 6.5. The next, as I travel to the right there, I've got a minimum right here. I think that's the 0.2, but maybe it's not. So I'm just going to use the calculator to help me verify that. So second trace, I'm going to go to the minimum tool, and I'm going to move. I'm going to be to the left, move over to the right, enter, move back toward that, enter, and here's that weird looking thing again, negative 1.808 e to the negative 6. So that's 5 zeros in front of the decimal place, or after the decimal. So this is really 0.2 is what that is. So yes, that minimum is at 0.2. So we got maximum at negative 1.73, 6.5. Got a minimum at 0.2. And then let's find that other maximum for that graph. So I'm going to hit second trace, and I'm going to go to that other maximum. We'll go to the left of it, hit enter. Go to the right of it, hit enter. Guess, just move back a little closer. Positive 1.73, 6.5. And then we can sketch that graph out of that. Finding those key things. The turning points, there's 1, 2, 3 of them. On a polynomial, turning points will always be at most 1 less than your degree. Okay, so maybe that's something we'll make a note of here. Turning points will occur at most degree minus 1. So if your degree is 4, the most turning points you could have would be 3. If your degree is 5, you could have at most 4 turning points. That doesn't mean you automatically will have that number of turning points. That just means that's the most you could have out there. So at most limits that. So degree minus 1 gets you the number of turning points you could have at the highest amount. Okay. All right. How can you use the graph to estimate the average rate of change? What is the average rate of change? What is that? Over an interval. It's slope. So average rate of change is a slope over the interval from -2 to 0. So the interval, these are x values. If we're going to find the slope, we need y values that go with them, right? So we need the ordered pairs for -2 and for 0. For this graph, f of -2 and f of 0, that's what we're looking for. I've got it on the calculator if I want to use that. I can hit trace -2, and it gets me the y value of 6. If I put trace 0, that's that y-intercept we have, 0, 2, for that graph. So those are my x1, y1, my x2, y2s. And we're just going to find the slope of the line that would connect those two dots. So the average rate of change is the slope. So we're taking, I'm going to do 6 minus 2 over 0 minus -2. 4 over 2, which is 2. So the average rate of change is +2. If we look at that graph from -2, that's not +2, it should be negative. I mixed up my x values. I didn't do that correctly. Common mistake. That should be -2 minus 0, which makes that -2, which makes the slope -2. Negative slope, it makes sense that it's, and that's why I knew it wasn't right, because when I look at my graph, the 0.26 is here and 0.2 is right here. We know that that's a negative slope of a line that connects those two. So that's how I knew it wasn't correct. I knew I made a mistake somewhere. So that we should know that that's a negative slope because it's decreasing across that interval. Well, not completely across that interval, but the line would be a decreasing line out of there. Okay. So average rate of change, slope formula that we've used before, all that stuff is still involved here. Not doing away with pretty much anything we've done. We're still using it. All right, let's do a little try it here. I ain't worried about making a table of values. Let's identify the key features of this graph. And you don't have to draw the graph if you want to just use the calculator to draw the graph, but let's identify those key features. So remember, the key features that we're looking for are intercepts, maxes and mins, and then which are also, remember, those are also turning points. And what else? End behavior, which that's a good thing to note anyway. Let's see what we can do with that one. I should be able to do the end behavior without even graphing it. What's the degree? 5. So it's an odd degree. So I know the ends are going to go in what directions? Same or opposite? Opposite, because it's odd. What's the leading coefficient? 1. +1. That's in front of the x to the 5th. So positive leading coefficient, so that's a positive slope. So the left side, as x goes to -infinity, a positive slope goes like this. So the left side is going down. So that's going to be toward -infinity. Since they're opposite, The other one has to go toward positive infinity. So end behavior, we should be able to get without even typing it in the calculator. And that's what you want to be able to do with that, because if you're trying to gain time on EOC or ACT, doing things, if you've got to type in that whole problem in your calculator, you're wasting valuable time on things that you can know out of that. So now for the intercepts and the maxes and mins, yeah, we need the graph of this. So let's put it in the calculator and get that going. X to the fifth plus 18x squared plus 10x plus 1. Graph. Ooh, fun times. All right, so we got what looks like 3 x-intercepts to find, because it's crossing right here between -2 and -3. It looks like it's crossing twice between 0 and -1. Okay, so we got 3 x-intercepts to find, and then a y-intercept, it looks like. So I'm going to find that y-intercept first, because all I got to do is hit trace 0. And there's my y-intercept. That's the easy one. So I'll find that first. Y-intercept would be 0, 1. Now let's find those x-intercepts. So how do we do that with the calculator? Second trace. We're finding x-intercepts, which is another name for zeros. Hit 0. And I'm going to move over here to I'm just going to start on the left. And move. And then far enough, there we go. So again, here we have that weird rounding error thing. -5 e to the -12 is basically 0. So I'm going to round this to -2.410. Now I'm going to go try to find the next one, which is right here. So second trace 0, move around till I get to the left of that first one. Enter, move to the right of it, enter. Right there. -0.430. That one didn't have the rounding error. -0.430. Was that right? Yeah, 4.3. And then I'm going to try to find the next one. Second trace 0. At the bottom. Enter. Back there. -0.130. So I found 3 x-intercepts and a y-intercept. Will I always have 3 x-intercepts with an x to the 5th power graph? No. There's no rule about that out of there. But now I've got the intercepts. Next thing I want to focus on is the turning points. So when I'm looking at that graph, what do I know is happening up here off screen? Yeah, it's got a peak to it, right? So we got a maximum up there. So let's use the calculator to find that maximum that's on this left side here. So second trace maximum is option 4. And I'm going to move to the left. There I am to the left. We'll move to the right. There I am to the right. Just going to move back a little bit. And there I have a maximum -1.83, 22.46. So I have a maximum at -1.8. Can't remember these numbers. 83, 22.46. And then I know I have a minimum that I can see right here. Somewhere it's between those two x-intercepts that I found. But I'm just going to use the calculator, hit second trace, minimum. Move to the left, to the right, negative 0.28, sorry, and then negative 0.39. Make sure I round that correctly. Negative 0.28 and negative 0.39. So key features of that particular graph of that polynomial. Those maxes and mins, their turning points, and then, so what's happening on the turning points, we've got an increasing interval from left to right until we get to that maximum, then it decreases until we get to this minimum, and then it increases to infinity there. We talked about increasing and decreasing intervals back in topic 1. So that's going to come up again at some point here. So it's kind of reminding us of those things there. Last thing in this particular example is find the average rate of change over the interval from 0 to 2. So I need to know what f of 0 is and what f of 2 is. I know what f of 0 is. I got that point. It's 1. I just need to find out what f of 2 is. How much? Yeah, trace 2. That's the easy way to find it. 125. I don't know. It's not excessive if that's how much money you're paying me. It's a little lacking. I would like more than 125. Now, what do we do to find an average rate of change? Slope formula. y2 minus y1 or x2 minus x1. So 125 minus 1 over 2 minus 0. 124 over 2 be 62. So the average rate of change, and that makes some sense. I mean, if you look at the graph, that line, if it connecting that y-intercept with that other point, that's a pretty steep line, and so it should have a large positive slope. That makes sense that it's a pretty large positive number there. All right. This is where we start pulling in some stuff from Unit 1, or Topic 1. And it's asking us, it doesn't give us an equation at all, so the calculator really doesn't help us much on this. So this is where using the ideas and being able to visualize things here. It says, how can you sketch a graph of polynomial function from the verbal description? So it's just giving us clues about what it looks like. F of x is positive on the intervals from negative infinity to negative 4 and from negative 1 to 4. So if a graph is positive, where's it at? This is where we got to remember things from topic 1. And we did this a little bit in topic 2 as well. If it's positive, where does it live? In quadrant 1 is one place it could live, because what do we know about quadrant 1? So maybe yeah, all right. So on your coordinate plane, f of x is y values, right? So y values above the x-axis are all positive. So quadrant 1 and quadrant 2 are both positive y values. Okay? Now it says over the interval from negative infinity to negative 4. So let's just draw us a little coordinate plane over here. Maybe not so little, but just draw, one that has a nice average size to it there. Now it says it's positive from negative infinity to negative 4. So that means x values. This is what intervals are. Intervals, x values. That's when it's talking about intervals, it's talking about x values. So from negative infinity all the way to negative 4. So what do I know is happening at negative 4? It's hitting the x-axis there, right? Because if it's positive from negative infinity all the way to negative 4, 1, 2, 3, 4, there's an x-intercept right there. Where does it start being positive again? At negative 4 or at negative 1. So at negative 1, it hits the x-axis again. It stops being positive where? So the first line says it's positive over the interval from negative infinity to negative 4. And then must dip down below here and get back up to positive from negative 1 all the way to 4. So I got another x-intercept right there. It's negative. F of x is negative from negative 4 to negative 1. So that's a little loop down here. And from 4 to infinity. So that's down here. Notice I haven't drawn the connecting pieces yet because I got all this other information here. It says f of x is decreasing on the intervals from negative infinity to negative 2.67. So that means it's going down from negative infinity. We're decreasing until we get to the x value of negative 2.67. Where's negative 2.67? Here's negative 2. Negative 2.67 is about there. Do we know the y value that goes with that? Huh. We don't. But where do we know it has to be? Because f of x is negative from negative 4 to negative 1, negative 2.67 is between those two, right? So we know the y value has to be somewhere in quadrant 3. It doesn't matter where as long as it's somewhere in quadrant 3. So I'm just going to put that negative 2.67. I'm going to put me a dot maybe down here. That's good enough. It doesn't matter. If you wanted to go further down into quadrant 3, you could. That wouldn't be wrong. And then it says, okay, it's negative from negative infinity or from negative 4 to negative 1. So I know the graph is doing this sort of thing. And I know it's decreasing from negative infinity down here. Then it's positive from negative 4 or negative 1 to 4. But here it says it has a decreasing interval from 2 to infinity. Where's 2 at? It's right here. So there must be a maximum in here somewhere. So that I made that y value up because I don't know what it is. I just put it at the x value of 2. It's got a maximum right there. It's increasing over the interval from negative 2.67 to positive 2. That's an increasing interval. It's going up and to the right, correct? It's decreasing from negative 2 or from negative infinity to negative 2.67. That's where that's at. And it's decreasing from 2 to positive infinity. That's a decreasing interval there. So based on this verbal description, we were able to get a graph of a polynomial. Go ahead, Case. Yes, that's exactly what it is. It's a rough estimate. There are some things that are absolute about it, like the x-intercepts. They have to be on the right spot. But your your x values are going to be, yeah, they got to be in the right spot. But your y values are going to be a rough estimate of where you think it might be. Because technically, there's 14 of us in here, or 13 of us in here today. There could be 13 different answers as to where this point is and where that point is. These points, though, they have to be that. The end behavior has to be that. But everything else is, like Kay said, a rough estimate of where you think it's going to happen. Okay? Much easier when you got an equation because it's yeah. I know it's this, it's got to be that because the equation says it's that. But here we're getting just some basic information and trying to build off of it. So let's try that again with this one. Use the information below to sketch a graph of a polynomial given this information. Okay. See what you can do with that one. See if you can get the x-intercepts in the right spot. Get the get a rough estimate for everything else, other than the maxes and the mins. Maxes and mins, the x values of those everybody should be the same, but your y values could be different. Freeze it. These things. What are our x-intercepts on this one? What are all the x-intercepts? Should be 4 of them.
-2, -1, and 1 and 2.
1 and 2. Yeah, -2, -1, 1 and 2. Right there, the positive intervals and the negative intervals. That's where you find your numbers for your x-intercepts. Positive intervals, negative intervals. These are where you're going to find your x-intercepts. Okay, so on these things, that's where you find your x-intercepts. Okay, and then the increasing and decreasing those are where you're going to find your maxes and mins. That's where you're going to find those pieces. So to find the x-intercepts, you need to look at your positive and negative intervals. Those numbers that it gives you there about where it stops being positive and starts being negative, those things, those are going to be your x-intercepts every time. Your maxes and mins are going to come from your increasing and decreasing intervals that they give you. That's always where that stuff's going to come from. And they will be between your intercepts, always. Okay, somewhere between them. Just so happens they're halfway between on this one on both of those out of that. So my graph looked like this. I got my x-intercepts, -2, -1, +1, +2. I put those dots on there first. Okay. And then it said that it increased from -infinity up to -1.5. So I knew that it was doing this, and that at -1.5, there was a maximum. I put mine at -1.5, +3. I could have put it at -1.5, +1, +167. It doesn't matter there. That y value is arbitrary. That's your rough estimate number. You just pick something. Because you don't know, the equation's not there. You don't know what it is. But we know the x value has to be at -1.5. And then it told me that from -1.5 to 0, it decreased. So I knew that down here at x value of 0, there was a minimum. Okay, so 0, and I picked -6 for no real reason. I knew it had to be a number down here on the y-axis somewhere there. I could have picked -1 if I wanted to. It'd have been fine. That's the rough estimate number. You just pick something. Okay, but the x value has to be 0. Here's my next x-intercept, and it said it was increasing from 0 to +1.5. So that's how I knew that there was a maximum right here at 1.5. I picked 1.5 +2. I could have easily picked 1.5 +5. It doesn't matter as long as the y value is up here in the first quadrant there. The x value has to be 1.5 though. Okay. And then my next x-intercept was the 2, 0. And then it said it decreased from 1.5 to infinity, so I knew it just went on forever that way. Okay, so using those clues to kind of get a rough estimate of the graph without an equation. Definitely easier if there is an equation to find those pieces. But here, realizing, hey, if we have those pieces, we can get an idea of what the graph looks like without having an equation even. If we just know those important points or those key features of the graph. All right? I don't know if we're going to get finished today. Probably not. That's okay. We'll finish it tomorrow morning, and you'll get some time to work in class tomorrow. Might be good. So here we got a word problem. So let's see if we can interpret this and see if we can build through it. All right. So in a science class, Abby mixes a fixed amount of baking soda with different amounts of vinegar in a bottle capped with a balloon. She records the amount of time it takes the gases produced by the reaction to inflate the balloon. From her data, Abby created a function to model the situation. For x quarter cups of vinegar, it takes t of x, that's time, in seconds to inflate the balloon. How long would it take to inflate a balloon with 5 quarter cups of vinegar? So what do we do with the 5? Yeah. Whole lot of word problem for a part just to be plug in 5 for x. Really easy.
Can I have your attention, please? Seniors,
Okay,
we plan
so,
on going on the Mississippi State
plug 5 in for x. Work that out.
Permission slips are going to be due on Wednesday.
I'm going to use the calculator to help.
Please pick those up in the AIR's office if you need one. Thank you.
-0.12 x to the third plus x squared minus 3.38 x plus 13.16. All right, we'll finish up the lesson tomorrow. and get the practice in class tomorrow. Okay. Appreciate your attention today. Welcome back from fall break.